talk. Can you hear me? Where's my phone? Yes, now? Okay. You see? All right, it works.
Does it work?
From the YouTube now too, now that I've done this. See the dot? See?
Okay, good. Great.
Science.
Oh, this is Let me, sorry, can I put this on yeah. Good afternoon, everyone. Good afternoon. So my name is Zion Sealy. I am the Marketing and Communications Manager here for the College of Communication, Architecture, and the Arts. And I would like to welcome all of you to the kickoff of the CARTA Generative AI Conversation Series, powered by Reekolect. A special thank you to all the students that are here from CARTA, as well from the College of Engineering and Computing, who also this past fall recently launched their master's and their bachelor's degrees in data science and artificial intelligence. So this talk is a critical part of how the world works today, right? Who here has interacted with AI in some way? Right, we all have. So at CARTA and within the university, we really want to make sure that we are at the forefront of these conversations. So we bring in experts such as Dr. Leach to be able to speak on generative AI, and we hope that this series will be something that continues to advance that narrative. And so today would not be possible without some key contributors from the field and within the university. So at first, I'd like to acknowledge the Dean, Mr. Brian Schreiner, Dean of the College of Communication, Architecture, and the Arts. Thank you for your unwavering support. Mr. Octavio Vicedo, CARTA Assistant Dean of Strategic Initiatives. Our partners at Reekolect, Mr. JC Silva and Amar Miko. And without further ado, I'd like to introduce Mr. Dr. Neil Leach. Dr. Leach is the co-founder of Digital Futures, a global online educational platform. He's also a NASA researcher developing 3D printing technologies for extraterrestrial applications. He's a member of the Academia Europea, which functions as the European Academy of Humanities, Letters, and Science with over 50 Nobel laureates. Dr. Leach is also a published author. He has over 40 books in architectural theory and digital design. And today he will be giving a talk on intelligence, AI, and the future of architecture. So without further ado, please help me welcome Dr. Leach. Thank you, Zion. I gave a talk 2 years ago, and that's a long time ago in the world of AI. I mean, one day is a long time in the world of AI. Could I just ask, who was there at that talk 2 years ago? Okay, not so many. Okay. So there's a lot's happened since then. Some new tools, including this one, which I will talk about later, and some very significant developments, and also I think a reappraising of what we thought we knew. This is a very kind of interesting new domain. Uh-oh, what happened there? Okay, so last time I titled my talk Alien Intelligence, and this time I'm going to call it Intelligence for reasons I will explain right now. This is not going to be a technical talk. On Digital Futures, we have a whole series of tutorials of how you use these tools, digitalfutures.international. And
Other things I put on my Instagram. If you've got any questions at the end, we don't have time to answer. Just ask me on my Instagram. This is I want to thank Reekolect for really helping out here and building upon, I think, something that we've already got that's very strong here. Next week, we have Manuel Jimenez Garcia, who is the leading 3D printer in the world. Absolutely astonishing guy. Used to work for Zaha, collaborates with Ross Lovegrove. He will be talking, followed by Wan Yu Ke, who was one of our Doctor of Design students. She is a world leader. In fact, AI, we are actually world leaders here at FIU in AI in many ways. Blazer Goriakos is someone I'm going to mention a lot. He actually won't be probably coming this semester, but next semester. And we're hoping to wrap things up at the end of next semester with Patrick Schumacher, who's agreed to be part of this, and Refik Anadol, who is a rock star in the world of media art. And we're planning to hopefully hold this down in the Gary New World Center. So why am I calling this intelligence rather than alien intelligence? These are the two networks, the neural network of the brain and the artificial neural network on the right. Briefly, if I were to summarize briefly and very inaccurately, AI is like a digital brain. It's like a digital brain. In fact, these neural networks are modeled on the brain, and indeed the circles on the right are called the neurons, and the lines connecting them are the synapses, and so on and so on. It's loosely modeled on the brain, but it's not the same as the brain. They're very different. AI is a mechanical system. It's a rigid mechanical system governed by weights. The brain itself is a kind of biological system that's very dynamic and active and continually mutating and changing. They're very, very, very different. And AI doesn't have consciousness, it's not sentient, it's not self-aware, and so on, but our brain is. However, what I want to argue is that that doesn't matter. They are still forms of intelligence. Birds fly, so do planes fly. They're different. Bird is completely different to a brain, and in fact, to a plane, and it flies in a very different way, but nonetheless, they both fly. And I want to make that same argument about AI itself. It is a form of intelligence, different to the brain, but definitely a form of intelligence. The other interesting aspect about this particular image, the Wright brothers with their first ever plane, is that once you've effectively worked out how to fly, the rest is kind of history. And this was an argument that was made by Blazer Goriakos, who was on Digital Futures just recently. He was saying that in a way, we are already at the stage that is known as AGI, Artificial General Intelligence, where AI is capable of doing many different things at a level where it's beginning to compete with human beings. This is something we thought was going to take a long, long time, but it's upon us before that we realized. And he argues that we are already in the early stages of AGI, which is hugely, hugely significant. He also, in his work, he's responsible, he works at Google, responsible for predictive text. So when you use Gmail, it suggests the next word in the sentence and so on. And they were working about 10 years ago or so. But they've now discovered that actually intelligence itself is a form of prediction, which is kind of mind-blowing in itself. And I won't say much more about it because Blaze will be talking about it. So they say that a week is a long time in politics. A day is a long time in AI. But I want to take a week in October as the kind of framework for talking about some of the things I'm going to talk about today. And I want to try and bring in some of the speakers in the future in the series as I talk. So we had Blaze on Digital Futures talking back on, as we invited for the 6th of October. Astonishing talk. That was on a Sunday. By the Tuesday, the first ever Nobel Prize had been awarded to Geoffrey Hinton. The Nobel Prize in AI had been awarded to Geoffrey Hinton. And by the Wednesday, the second ever Nobel Prize had been awarded in AI, had been awarded to Demis Hassabis. He was actually working in the area of chemistry. And by the Friday, we had Elon Musk showing us his Optimus humanoid robot, which probably this time next year will be everywhere. So from the Sunday to the Friday, the world changed quite significantly. So let me start by talking about these two guys, both British. I mean, I'm always getting in trouble for talking about the British, but they have had a huge role in the history of AI. Both of these guys were graduates from the University of Cambridge, and both of them interested not just in AI, but in the mind itself, in neuroscience. In fact, Demis Roussadis did a PhD in neuroscience. I graduated from Cambridge, also interested in AI in the mind. I'm still checking every year to see if I can get my Nobel Prize, but seriously, there was one other person who was also from the University of Cambridge and also British, who should have got one, Alan Turing, who was the great genius who tragically died in 1954, but he was the one who predicted AI. He was the one who effectively launched computation as a whole. In fact, the term AI was not coined until for an event that took place in 1956 in Dartmouth College in the States, where all the smart young minds that got together. I should put a pointer on this. Anyway, the guy at the middle, at the back there is Marvin Minsky, who became famous at MIT Media Lab, and Claude Shannon on the right-hand side. They start off in a very optimistic way. They were going to solve the problems of AI in 2 years. That never happened. In fact, when they got back together, the survivors here got back together, and this is John McCarthy, who actually coined the term AI. He wasn't very happy with the term, but he said we had to call it something. And I don't think it's a very good term. Synthetic intelligence, maybe, mechanical intelligence, but anyway, we're stuck with that now. When they got back together in 2006, they had to admit they'd achieved almost nothing. The first 50 years, despite all the hype, had achieved very little. They'd hoped to be, it was during the Cold War, they hoped to be translating what the Russians were saying, what the Soviets were saying. It was useless. And there were two things basically, I think, that held us back. Firstly, the computers were just not powerful enough. And secondly, they'd been backing the wrong horse. There were 5 different approaches towards AI. One of them was looking at neural networks, but that fell out of favor. In fact, Minsky published a book with Seymour Papert saying they're going nowhere, so forget them. And instead, we've been pursuing symbolic AI, which is based on logic. And it wasn't really getting us anywhere. Meanwhile, this character was refusing to buy into that and stubbornly pursuing the logic of neural networks. Geoffrey Hinton comes from a very distinguished family in the UK. His great-great-grandfather was George Boole of Boolean geometry fame. His great-great-uncle was called Everest. He was the one who gave the name to the mountain. And in fact, Geoffrey Hinton's middle name is Everest. And he studied architecture for 2 days at the University of Cambridge before deciding it was not for him. I got a friend at Foster & Partners who says he's smart. It took me 5 years to realize architecture was not for me. But anyway, fortunately, he moved into the world of computer science eventually, and he almost, or rather accidentally almost, because he was interested in the mind. And just he made a neural network to model the mind, and he became an AI specialist. But he was the one who was stubbornly persisting, because he was convinced the way we should get to AI was through understanding how the brain worked. And eventually, that began to happen. It happened really for one particular reason, and that is the invention of GPUs, graphic processing units that were not invented for computers. They were invented for gaming. But they discovered that they suddenly made computers much, much more powerful and much, much faster. And all of a sudden, neural networks began to work. So what we have now, and what Geoffrey Hinton is responsible for, is called deep learning, which is the most advanced part of AI. What we're talking about these days, ChatGPT, Midjourney, DALL-E, Sora, and so on, it's all deep learning. And it was because of Hinton, I would argue, that we now find ourselves in that situation. It's called deep because of the number of layers in a network. Hinton is known as the godfather of AI, and Fei-Fei Li, whom we're also hoping to get in this series, we don't know if we can or not, is known as the godmother. She's now working on spatial intelligence, which I think is probably extremely relevant to the world of architecture. And back in 2012, she was a young student at Princeton, and she organized a competition called ImageNet to see who could recognize images the quickest. Now, we've all got this on our phones now. We all got facial recognition. It's nothing special. But in 2012, we didn't have this. Anyway, Hinton came along with his team, including Ilya Sutskever, who's now a famous figure in the world of AI. He was part of OpenAI. And they came along with a neural network. This was an obsolete technology, a bit like a steam engine. Everyone was sort of joking about it, right? But they came in and they wiped the floor. They wiped the floor, and everyone was truly astonished. Fei Li, they recognized this image of a bird much quicker than anyone else. And Fei Li, in her autobiography, she says it's a bit like the world speed record for an automobile was beaten by 100 miles an hour by someone driving a Honda Civic. Now, I'm not sure if that's an exaggeration or not, but it caused a real upset. And everybody all of a sudden said, well, of course, I always thought neural networks are the way forward. But the holy grail for people in AI was really not to recognize an image, but to generate an image. And out of that, they realized that if you just reverse the flow, and instead of going from left to right, you went from right to left, you could actually generate an image. Start with the word bird, or start with the word, and you'd get an image. This is known as Deep Dream. This was developed by someone from Blaze's team again, called Alex Morvintsev. It's all over the place. It's kind of, there's no sense of where things should be positioned, but this was the first shocking, trippy kind of images that came out, and the first ever exhibition on AI generated art was curated by Blaze himself in San Francisco in 2016. But then something else happened. This guy, Ian Goodfellow, developed a more rigorous systematic approach called the GAN, the Generative Adversarial Network, where you have these two neural networks that are working against each other, the generator and the discriminator. The generator kind of generates images out of random noise, and then the discriminator judges them against a training set and decides whether or not they're good enough. And in so doing, it kind of improves, it trains the generator to become better. It's a bit like you and your tutor. You produce a project and your tutor says, that's rubbish, go and do it again, and so on. But anyway, this had automatically started producing things that were quite astonishing, much better. These are the very early GANs. But meanwhile, in architecture, we were completely asleep. In 2019, I teamed up with Patrick Schumacher of Zaha Hadid Architects, with Refik Anadol, who's now a rock star in the world of media art. And we were sponsored by Blaze. We had, the Google were funding us. We had an incredible dream team. And I applied for to curate the British Pavilion at the Venice Biennale, and we got nowhere. We weren't even shortlisted. Nobody was thinking about AI in 2019. And what we were hoping to do basically was to hallucinate not faces like the last one, but buildings. Anyway, Refik decided he was going to do it anyway. And he got all the images from the Zaha office, and he trained a style GAN on those images. And this is a long, laborious process, but he managed to do that. And eventually, what you can do is even though Zaha, she died in 2016, even though she's no longer around, you can produce a kind of an image, a design, shall we say, that looks vaguely like Zaha. And in a few seconds, it was the first ever GAN-generated image of a kind of architectural design, shall we say. And that went on the front cover of my book, which was the first book on AI and architecture in English, came out in December 2021. And there followed 5 other books in the next few months, all talking about AI and architecture. This is now coming out in the second edition. Is coming out in a few months' time in 10 different languages. Anyway, let's see. I hope it's going to have an impact. It'll be out of date by the time it comes out. Meanwhile, others were working on other versions of GANs. This is the work of Daniel Bolojan, who was teaching here for a while, is now a professor at Florida Atlantic University, working with Corp Himmelblau, where they used a cycle GANs, which is a kind of way of breeding things. So you take two GANs and play them off against each other, and they produce this. This is actually the work of the office of Corp Himmelblau, played off against geological formations. And that was really the kind of state of the art at the time. It's a bit glitchy and things, but it was kind of vaguely like a building. And that's what we put on the front cover of what was the 4th book on AI and architecture at AD that came out in May of 2022. All this was out of date by July because this came along. It wasn't actually released immediately, but DALL-E is a new technique. This is what you're basically using now. When you're using Midjourney, it's a technique called diffusion. It works in a very different way to a GAN. It's based on an image being using a diffusion process to disrupt an image, then repair an image. and it's based on text to image. You put in a prompt, in this case, an astronaut on a horse. And what is so remarkable about this is that there'd never been an astronaut on a horse, but you're able to generate an image of what it would have looked like. An AI, I should say, does not copy. Anyway, Refik was involved in this again and was using this technique because he'd been given access to it. And this is effectively the first ever diffusion model technique, image of a building, which he did in collaboration again with Zahedid Architects. So I want to get those two together for the end of this particular lecture series. And this was clearly much better. It has a sense of kind of three-dimensionality, materiality and things. And more importantly, we can all do this. It's easy. It doesn't take ages to do. It produces these images in 3 seconds. You haven't got to be a computational expert, and the quality of the resolution is much, much better. So this has been a complete revolution in terms of this. And this, I think, was where most people started paying attention, because at last we were getting these kind of images. And anyone can do this. Anyone can do this. You haven't got to be an amazing designer to do this. What I would argue, though, is these are just kind of superficial at the moment in terms of the process of design. We'll see other ways of operating that will become more important. At the same time, it's pretty astonishing, because what it's showing is that AI can design. It knows what the size of a palm tree would look like compared to, it knows what the size of a person would look like, it understands scale. It's effectively designing these. And the terms I use in my prompts, I don't specify palm trees or people or whatever. It just puts them in and it gets the scale right. So there is something truly astonishing about what these technologies can do. But at the same time, I think they're limited in how they're going to, the impact that they're going to have on society. And you don't just have to do buildings, you can also do fashion design, you can do cars, you can do whatever. Here's a design for a Mercedes I designed for Brian. If you're not happy with a Mercedes, I've got a Rolls Royce for you there, Brian. Anyone could do this. And it really was quite a shocking development. But the real thing is going to happen. Oh, sorry. The next thing that we came across was February of last year, when suddenly we went from text to image to text to video. Now, we'd had that since November of 22, but nothing as good as this. This is OpenAI Sora. And you're using text again. It's connecting with the video, and it's generating something that's pretty astonishing. It maintains consistency. And in a few seconds, you'll get a close-up of the face where you realize it's something truly astonishing. It is extremely capable. And everybody started paying attention, was completely shocked by this development. But interestingly, OpenAI didn't release this for some time. So we kept waiting. Now, what this can do also is it has certain abilities that it's learnt. There's a thing called occlusion in the world of computer science, which means when something disappears out of the picture and comes back in again, and it can maintain consistency, that is pretty special, and it's learned to do that. In this subway train through Tokyo, you lose sight of this background image, and then it comes back. What's more, it's got a very incredible sense of 3D. This is a Victoria crowned pigeon. Amazing detail, right? But then when you watch it turn its head, you just watch it turn its head, the sense of 3D is astonishing, absolutely astonishing. And I was showing this in various lectures around the world, and one of the guys who was in the audience said, well, actually, I was testing this out. And I said, tell me more about it. So I can't tell you anything about this. I've signed a non-disclosure agreement. And I said, well, instead of saying this can do this, or this is, maybe you could say, this might be able to do this, or this could be this. And basically he was saying we're getting very, very close towards 3D. Now, architects would say, well, fine, birds, easy. Can't do architecture, can it? Not true. This is Sora doing in some interior design. Not very special, but interior design nonetheless. It's able to do that based on a short prompt, and you can get that. Now, Sora was not available until December, until a few weeks ago. But there are other platforms that came along. Runway was one that I use, Runway Gen 3, And what you can do, you couldn't keep the consistency as long as this at all, but you could kind of do some videos, you could crop them, and you could put them upload on Instagram with some music, and you could produce something that was almost as good. So this is what the kind of things I was experimenting with over the last few months. This is an interior of a gallery, and I didn't specify anything. This has been generated by Runway. It's totally been designed by Runway. And there are glitches, of course, but it knows what people look like when they're walking, it knows the size of them, and so on. This is, I would, if you told me a year ago that we could do this, I would have been astonished. I said, no, we can't do those, but no way. Well, things change rapidly in the world of architecture, and you guys can all do it. The prompts are fairly straightforward. And likewise, you can also do the exterior buildings. There might be sound on this one. And you can do Brian's car. I should say that was an image generated by Midjourney that was animated by Runway. And then Sora came along. Sora was released middle of December, and all of a sudden we began to realize this was the thing. This was the best thing. I think there's also sound on this one. Also, these are my hats, okay? Also with Sora. One week later, everyone was saying, wow, that's incredible. 1 week later, Google launched VO2, which is even better. So let's just show a short clip of that. Things are just changing so rapidly in this domain. Filmmakers, they're making films, they're making movies already using this kind of technique. I'm just truly astonished by what you can do with these things. And everyone here can do exactly this. It's a bit expensive, I've got to say, but you can all do this. Okay, so, but that is not, I don't think, what's going to be the future of architecture. It's going to be, the way in which an office works is going to be based on a more automated sort of process, dealing with, using data, automating the process, and optimizing everything. And I just want to give you a glimpse of our very own Wan Yu He. She was a graduate on the Doctor of Design program. And she is kind of, I think she's going to do to Autodesk what SpaceX did to NASA. She has got the most extraordinary practice or development firm called XCool. It's called XCool because she used to work for Rem Koolhaas. XCool equals Rem Koolhaas, X-Koolhaas. And he actually is now, Rem has been visiting her office to go and see what she's doing. And she was so kind of frustrated by the inefficiencies of working at OMA, she decided to go and take it on herself to go and do different things. I'm just going to give you a little glimpse. She's going to be giving a talk in this series, a little glimpse of some of the work that she was doing. This was a project that she actually won in a competition against 200 other architects. And what they're doing is using a form of optimization, or generative AI, to optimize for performance questions. This is all the work of Thomas Spiegelhalter, of being concerned about environmental questions. And they're taking this rectilinear form is being broken down or eroded by a process of wind comfort, where it's beginning to turn it from these rectilinear forms into more kind of, shall we say, Gary-like curvilinear forms. And eventually you end up with a design. There are many ways in which they used AI in this particular project, but what was significant, they won the competition, first of all, and secondly, they built it. This was the construction just a couple of months ago, the first ever generative AI project. This is the sign of the things to come. But let me move on to Demis Hassabis. He was a prodigy, a chess prodigy when he was 9 years old. He played for the UK team, extremely talented, did a PhD in neuroscience, as I said. Then he set up a company called DeepMind in London. And what they were interested in DeepMind was not necessarily just AI itself, but how you can use AI in other disciplines. And in fact, he got his PhD for chemistry, not for AI itself, it's for chemistry, because they could predict the structure of proteins. Now, over history, there have been various moments when the public doesn't really maybe understand what's going on in these research fields and things. It's very difficult to follow if you're a member of the public, and you need a kind of high-profile event that is kind of accessible to realize what's going on. And back in 1997, there was one such event where Garry Kasparov, who was the world chess champion, took on IBM's Deep Blue. Nobody thought he would lose. Yeah, Kasparov, one of the greatest players of all time. He couldn't possibly lose to AI. But that's a mistake I think a lot of people make. He was beaten. And he makes this comment, just to understand that everything we know how to do, machines will eventually do better than us. Now, that was easy, chess, because it's kind of organized in a way, whereas the game of Go is much more challenging because you can put your stone on anywhere on the board. And in fact, there are more potential moves in Go than there are atoms in the universe. There are more potential moves than atoms in the universe. So they had to kind of buy into this kind of new logic of deep learning that Geoffrey Hinton was doing in order to go and pursue that. And this guy on the right is the kind of Garry Kasparov of Go, Lee Sedol from Korea. And again, nobody thought he was going to lose. Lee Sedol, he was a genius. No way was he going to lose to a robot, to a computer. But something happened in this match, which was, I think, pretty astonishing. This is after game 2. He says, yesterday, after game 1, I was surprised. But today, I am speechless. Something happened in game 2, and this is the famous move 37. The black stone with the white circle in it is move 37. And everybody thought it was a mistake. They thought, oh, the computer's made a glitch again, stupid computer, it's not going to get anywhere. But it wasn't a mistake. And 100 moves later, it joined up with 2 of the black stones on the left-hand side and it won the match. It's as though it was thinking 100 moves ahead. Now, this is what the Google commentators thought of the move.
From the Google team was talking about is this kind of evaluation value.
That's a very surprising move.
I thought it was a mistake.
But it was no mistake. Afterwards, Lee Sedol said it was basically way more creative than humans. I'm not quite sure that I'm not quite sure if it's being creative, but I don't think that was the most significant thing about it. What it showed is AI could operate off the spectrum. We couldn't understand it. Those of you who got dogs know that dogs can smell or hear a much greater range of sounds and smells than we can. This is what AI is doing. It's operating off the spectrum. And as it gets more and more intelligent, we will not be able to keep up with it. They predict that by 2033, AI will have an IQ of 1,500. 1,500. Basically, that's a bit like we'll be to AI like an ant is to Einstein. It's that kind of thing, and we will have no clue what's going on. But if that was surprising, the next one was even more surprising. The next generation of AlphaGo, which used deep learning even more. And this was a system that not only beat that first model, 100 games to 0, but it taught itself to play Go by playing games of Go against itself over time using reinforcement learning. It played 3.9 million games of Go over 3 days. And you think, wow, that's a lot, right? But when you think about it, that is a lot. That's 20 games of Go per second. I hope this hummingbird's going to start beating its wings. Okay. This is I'll hope it'll do it. This is admittedly, it's a slowed up video of a hummingbird, but 20 games of Go, they're about 3 beats per second, possibly. It's 7 times this. This is mind-boggling. And I don't think we paid enough attention to this, because this was showing us how scary AI could be. And I just want to declare right now, I am every day more and more amazed by AI, but also more and more terrified. I find this totally terrifying. We'll have some even more terrifying examples. Now, when that came out, the guys in the Go playing nations in China and Japan and Korea, they thought, we got to invest in AI. This is the thing to do. They called it the Sputnik moment. Sputnik was when, I think 1957, when the Soviets launched a satellite into space, and the Americans realized, wow, we've got to catch up. And that led to the founding of NASA, going to the moon and so on. This was a Sputnik moment. But the bigger Sputnik moment for the rest of the world was this moment, the launch of ChatGPT. Now, I don't know if you know the story about this, but this was launched on November the 30th, 2022 by OpenAI. On January the 1st, sorry, November the 1st, 2022, there were no plans to launch this at all. In fact, they were working on GPT-4, which was the next model that they were working on, but it was kind of spewing out hate speech. It was being racist, all these things. The problem with these models is they're trained on human data, and they get our biases and our racism and so on. So they had to clean it up. So they thought, we can't release that. At the same time, we've got to worry about our competitors. So they said, well, let's go and launch a chatterbot, they called it first of all. Then eventually became called chatbot. The middle of the month, they said, okay, let's go ahead with this. And they didn't think it was any big deal. They said, this is going to be an internal research preview. We're just going to test the market, nothing special. And of course, when it came out, it exploded, totally exploded. And there were jokes going around the office, internal research preview, right? Because all of a sudden things changed. And this changed everything in the whole world. Elon Musk had walked away from OpenAI, and he thought, okay, I got to get back into it. He's now his own company. Zuckerberg was more interested in the metaverse. He's now realized it's all going to be about AI. This has suddenly was the catalyst behind everything. But the disturbing thing about this was, for the first 50 years, AI had failed to live up to its promise. Now, all of a sudden, it's doing better than we ever thought, and it's getting unnerving. How is it doing all these things? If ChatGPT can write code and translate languages, nobody taught it that. How is it finding out how it's going to do these things? They call these emergent capabilities. And they thought, well, what's happening here? Because these large language models, this is really what you should be talking about, large language models. Doesn't sound very sexy, right? That's the thing. Now, these large language models are not large, they're gigantic, they're huge. They're trained on trillions of bits of information and millions of parameters. But what is really interesting about them, the more data on which you train them, the more they start behaving in weird ways. And computationally, they're not so sophisticated, just 200 lines of code. But the more you scale it up, suddenly these weird things get happening. So suddenly people get really unnerved by that and said, what's happening? There was a letter that was issued by the Future of Life Institute saying, please stop developing these things until we know what's going on. Elon Musk and many other people signed it, right? Complete waste of time. I mean, asking the leaders in the field to slow down, it's a bit like asking the leaders in the Olympic marathon to slow down. Of course they're not going to slow down because their competitors are going to catch up. And this letter had no effect whatsoever. When Google and Microsoft are competing against each other, no way are they going to slow down. Now, what was interesting about this was that Elon Musk realized this and then jumped ships into the other side. He is now going all in, making this supercomputer. Now, not just artificial general intelligence, we're talking about super intelligence. If I were to kind of summarize the situation in which we are right now, it's as though we are on a runaway train with no brakes, going faster and faster. That is the situation. So I'm going to move on to talk about Elon a little bit. So his Optimus robots are there as an assistant. And I think all that AI is doing in some ways is being an assistant that is helping you in what you're doing. And he describes here, basically, we're all cyborgs. Everyone here is a cyborg. We've all got, as he puts it, a machine extension of ourselves in our phone, our computers, and so on. We are already superhuman. Now, this is super interesting. It's a very crude graph, but one of the most important things I'm going to show you today. This was some research, early research done by MIT and Harvard, looking at the impact of using ChatGPT. Now, the blue mountain on the left-hand side are those who didn't use AI. And the green mountain is those who do use AI. And you can see a kind of 40% difference between the two. Now, what they looked at was quality, quantity, and speed, and they got similar readings for all of these things. So basically, you cannot afford not to use AI in the future. It's a bit like you can't afford not to use the calculator or to use spell check. You have to, and you can have a huge advantage if you do that. Now, how many of you have heard this expression? AI won't replace humans, but humans with AI will replace humans without AI. It's nonsense. It is totally nonsense, because when you think about it, what happens when it's not a one-for-one correlation. It's not one person using AI replacing one person not using AI. What happens if one person's using AI is going to achieve 40% more? In other words, the true correlation is going to be not one for one, but something like 3 humans will replace 5 humans without AI. Something like that. And as these machines get better, that is going to go up. So in other words, AI will replace humans, because what's happening is 3 people using AI are replacing 5 people. It's the AI that's replacing the 2 people that have been lost. AI is going to have that impact. Offices will shrink, not just in architecture, every single discipline will basically shrink because of the impact of AI. It's inevitable. The other mistake that I think we thought we made was we looked at these robots, and these are the Tesla robots in a factory, and we thought, well, it's not going to be the white-collar workers that are going to go, it's the blue-collar workers, the factory workers. They're the ones who are going to suffer. But what happened, actually, is that robots are still pretty clumsy. If you took a robot and put it on a table here and ask it to make a Lego wall, it would be like a 2-year-old kid. It would be very clumsy. Meanwhile, AI is racing ahead. And what we're discovering is that actually we're using workers to do the things that robots can't do, like stacking things in an Amazon plant. You know? And it's precisely the white-collar workers, the architects, the engineers, the doctors, the lawyers who are at threat. There is a perverse, there's a principle called Morovich's paradox that says basically what we can do, AI is not very good at, and what AI can do, we're not very good at. So one thing AI can do, and I forgot to mention about ChatGPT, ChatGPT knows 10,000 times more than anyone here, including Brian. 10,000 times more. Way beyond us. But it's not very good at doing things that we can do, like catching a ball. Really not very good. Now, this is where we get into the real Black Mirror episodes thing. So I want to just warn you in some way. This is what AI, this is a sign of what AI is going to be able to do in the future. This is Yuval Harari talking, well, I'll just let him talk.
There was an experiment when OpenAI developed GPT-4, like 2 years ago. They wanted to test what can this thing do. So they gave it a task to solve CAPTCHA puzzles. The CAPTCHA puzzles, like when you go online and you want to access your bank or whatever, and they have this riddle that you have to solve, an image that you have to say what are the twisted words and then letters to make sure you are not a robot. GPT-4 could not solve the CAPTCHA. But what GPT-4 did, it accessed TaskRabbit, which is an online site where you can hire humans to do different things for you. And it asked a human to solve the CAPTCHA for it. Now, the human got suspicious.
The human asked, why do you need somebody to solve CAPTCHA for you? Are you a robot? It asked directly, are you a robot? And GPT-4 answered, no, I'm not a robot. I have a vision impairment, which is why I can't solve the CAPTCHA, so I need your help.
This is really worrying, because at the moment, we're roughly on a par with AI, and we can guess these things. it won't be long before it's going to be running around us and running rings around us. Now, just to be clear, AI wasn't lying there. It doesn't know what a lie is. It doesn't think in those terms. It doesn't think, first of all. It doesn't, there's meaning doesn't belong to the world of AI. So it's just looking for the most efficient way of solving the problem. And it's looked at what humans would do, looked at all that data, and worked out the most efficient way is to go to do what it did. That is going to be extraordinary in the years to come. Now, so it is smarter than us intellectually. There's no question about that. It's going to get smarter and smarter and smarter. But it's also beginning to get much better at moving around. This image, this video, might seem not so special. If you know, those of you who can play baseball or tennis or cricket or whatever, you think, it's nothing special. This is a bit like the Wright brothers getting their plane to take off. Once you can do that, then the rest is is history. So I want to sort of play Geoffrey Hinton, who is worried about all this, and he explains why he's worried.
It made me realize that these digital intelligences have something we don't have that makes them much better. When one of them knows something, it can tell all the others. That's what we don't have with people. So imagine you had 10,000 people, and imagine if when one person learned something, everybody knew it. You could learn a lot more stuff, right?
Right.
And that's why things like ChatGPT knows like 10,000 times as much as any one person. It's because when you train it, there's lots of different copies looking at different bits of the data and learning stuff, and they can all combine what they learn instantly with a bandwidth of like trillions of bits.
So can they think?
Yes. So imagine the following scenario. I'm talking to chatbot, and we talk for a bit, and the answers it's given me seem a bit strange to me, and I suddenly realize that it thinks I'm a teenage girl. And I say, what demographic do you think I am? And it says it thinks I'm a teenage girl. So the question is, when I said I suddenly realized it thinks I'm a teenage girl, was that a metaphorical use of the word think, or was that just the same way as we use think? And I strongly believe that use of the word think, when I said it thinks I'm a teenage girl, was exactly the same way of using think as we do with people.
And so that was enough to make you say, what, this has accelerated beyond my comfort level?
I suddenly realized maybe they already are better, and making them more like real neural nets isn't the point. They're already better than us. They're a better way of doing learning. And if we make them bigger, they'll get much smarter than us. They already know more than any one person.
I understand that things could go awry, but I still think that people hear the notion of danger and they dismiss it as hyperbole.
I thought it was hyperbole for a long time because I thought these things were a long way off. I thought there will eventually be danger, but I thought focusing on it now is unnecessary because it'll be 30 to 50 years before these things get more intelligent than us. But this combination of realizing that they might have a much better way of learning than we have, because they can share knowledge instantly, and seeing things like ChatGPT or Palm at Google that can explain why a joke is funny, made me realize these things are already pretty intelligent, and if they've got a better form of intelligence than ours, then it gets to be much more urgent.
So, I mean, this is the guy, the godfather of AI, and he's getting very nervous about this development. He left Google so he could speak out of these things. The problem is basically this, is that we didn't think that they could even think. We thought they were sort of basic in some ways. And what we discovered, not only do they know 10,000 times more than us, they can begin to understand. He mentions the joke, right? This was the litmus test. Can AI explain a joke? Because if it can explain a joke, it must be able to understand that joke. And what he and Blaze are thinking is basically, these things understand. ChatGPT understands the questions. What's more, it's beginning to think. I mean, I put think in inverted commas, and they're starting to getting reasoning. So these things are kind of racing ahead. But the key question is that it can learn so quickly, like sharing with 1,000 other computers. During COVID, there was a thing in the UK called the R number, which if it was more than one, that was bad news because it was spreading. Less than one, that was good because it wasn't spreading. What if the R number were 1,000? What we're talking about is some kind of explosion, basically, of intelligence. In my work, I talk about the need for having a second Copernican revolution. The first Copernican revolution was when Nicholas Copernicus basically said that the Earth is not the center of the universe. The universe doesn't revolve around the Earth. No, the Earth revolves around the sun. I think we've got to change our attitudes towards AI and realize that we are not the center of intelligence in the universe. Our problem has been anthropocentric. We've been looking at AI and saying, oh, it's not conscious, it's not self-aware, it's not this, it's not that. Who cares? It's better than us. If you were AI looking at us, what would you think? You'd think, those dumb idiots know 10,000 times less than us. Or just recently, Thomas Spiegelhalter asked me to write a review of his book. I said, I haven't got time to read it. So we put it through ChatGPT. In 3 seconds, this 200-page book was summarized. It would probably take us 1,000 times longer than 3 seconds to do that ourselves. So compared to AI, we're kind of like lumbering like an elephant in some ways. The other problem is that people say, well, it's not sentient, it hasn't got feelings, hasn't got emotions. Well, this year is the anniversary, this is the year in 2025 in which the movie Her was set. And we all know the story of Her, basically that it can simulate emotions very, very easily. And there was this famous story just recently of some 14-year-old kid who fell in love with this AI chatbot and committed suicide. The problem is that we need to change that attitude and realize that this is the thing that is going to make a huge difference, is going to take over. Now, I'm going to not quite finish off, but this is extraordinary. This is Elon Musk and Joe Rogan. This is a submission for my course last semester for my my theory of AI course, where I asked people to write to do movies. This is Randy Carnett and Diego Lobo, and it's a fake video, and it's absolutely astonishing. If this doesn't terrify you, I don't know what will.
Elon, man, great to have you back on the show. Let's dive right into it. Artificial intelligence. You've called it a double-edged sword, right? A potential savior, but also humanity's demon. What's your perspective now?
Thanks, Joe. Yes, I've said we're summoning the demon, but it's more nuanced. AI is already transforming everything. Take how Neil Leach describes it. AI isn't just about robots. It's an invisible force in our daily lives, controlling algorithms that feed us ads, and even runs our phones.
That's wild, man. So AI is like this silent invader. But Neil also talks about this idea of extended intelligence where AI enhances us, not replaces us. Isn't that what you're trying to do with Neuralink?
Exactly. Neuralink aims to close the loop between human intelligence and machine intelligence. The goal is synergy. Neil Leach discusses this concept of humans as natural-born cyborgs, adapting to technology to become superhuman. It's all about augmenting human capabilities.
Yeah, but the danger's still there, right? I mean, Leach also talks about this second Copernican revolution. If AI becomes the most intelligent entity, we're no longer at the center of the universe, so to speak.
Absolutely. That's why we need to be cautious. If AGI, artificial general intelligence, surpasses us, it could become like an alien species indifferent to human survival. That's the existential risk. And yet, as Neil points out, AGI could also solve our biggest challenges like climate change or disease. The question is, how do we guide it?
So it's a tool, but a tool that could rewrite the rules. Do you think regulation keep up? I mean, the way Leach describes it, AI is already ahead of us in so many domains, from design to decision-making.
Regulation is key, Joe, but it's tricky. By the time governments act, technology has already evolved. It's like trying to regulate fire after inventing the wheel. What Neil highlights, AI's pervasive impact on architecture, for instance, shows how embedded it is becoming. We need proactive global cooperation to ensure safety.
Let's talk about the practical side of this. Neil Leach brings up this concept of AI as a designer force. It's not just about robots doing tasks, it's shaping everything around us. Do you think AI could take over the role of creators, artists, architects?
That's a good point. AI is already starting to push boundaries in design, whether it's architecture, art, or even music. Neil points out how AI is a tool that can help us create things we never imagined before. It's not about replacing humans, but working alongside us. The role of the human designer may change, but creativity isn't just about coming up with an idea. It's about the context, the emotion behind it, the purpose. AI can suggest patterns or optimize designs, but it doesn't have the depth of human experience.
Right. It's not just about the output, it's about the soul behind it. But I got to ask, you've always been vocal about AI potentially turning against us. If we do build this kind of super intelligence, how do we make sure it stays aligned with human values?
Yeah, that's where it gets tricky. Once we create AGI, it could be orders of magnitude more intelligent than us. If we don't design it with the right safety measures, it might decide that its goals, whatever they are more important than humanity's. That's why I think AI development needs to be handled with extreme caution. Neil talks about the possibility of a second Copernican revolution where AI shifts the focus of the universe away from humans entirely, and we're left as just a small part of something much bigger.
It's insane to think about. Like, we could be the ants in a world where the anthill gets crushed by some machine we created. But do you think there's hope, though? Can AI be steered in the right direction, or is the ship already sailing?
I think there's hope, but the window is closing. If we make the right moves now, we can guide AI to be a force for good. Like Neil says, AI has the potential to solve problems like climate change, disease, and even poverty. But the key is developing it responsibly with global cooperation. We can't just have one country or one company in charge of something this powerful. The stakes are too high.
Well said, man. It's going to be a crazy ride, but I'm glad we're talking about it now before it's too late. All right, folks, you heard it. Be careful with that AI, and remember, don't let it take over the pizza debate. We'll be back after the break.
I mean, that was totally automated. They didn't fabricate it and go in and insert these words. They took the text of my book, they fed it into the computer, they framed the whole thing. They give a long description. But this is astonishing. How do we teach in the age of AI when students can do this? Remarkable, remarkable. So don't panic. Let me finish off. Those of you who've read Hitchhiker's Guide to the Galaxy will probably remember on the back cover, there is this comment, don't panic. This was a cult book when I was at your age. It was kind of like going all over the place. It was the book to read. And this, you probably know let me skip this. But when Elon sent his Tesla into space, he actually puts this expression, don't panic, in the dashboard of his Tesla. So, but we shouldn't panic. And the reason why we shouldn't panic, I think, is that we are infinitely adaptive creatures, always adjusting to the world around us. I mean, for example, can any of you really remember what it was like before we had iPhones, before we had mobile phones, cell phones? Well, there was a time, and it wasn't so long ago, and I frankly cannot remember it. There were times when we had maps. We would try to find our way around cities with maps. So we adapt, we change. What is clear, the future is going to be very, very different to the present. There'll be incredible advances in science and technology. Offices will shrink. Offices will shrink. It'll be different. But my belief is we'll get used to this. I'm going to play Arthur C. Clarke commenting on these comments.
And yet, you know, human beings are almost infinitely adaptable. Look at the incredible changes we've experienced and survived from the Stone Age to the present time. And yet even greater changes are still to come, because the future is not merely an extension of the present with bigger and better machines and cities and gadgets. It'll be fundamentally different, and many of the things we take for granted will one day pass away as completely as spinning wheels and sedan chairs and oil lamps. And that is why the future is so endlessly fascinating, because try as we can, we'll never outguess it.
If I could just offer you one example of how we are an adaptive creatures. If when I was a young kid wearing shorts 50 years ago, somebody had said to me, in 50 years' time, most marriages would end in divorce. I'd think, oh my God, it's the end of the world. What's going to happen? Well, in the States anyway, most marriages do end in divorce, and we're quite okay with it. The future's going to be different, and we're going to be quite okay. I'm going to finish on a very British note. Keep calm and carry on. Thank you. I don't know if anyone wants any questions or whether you want to rush to the studio, back to the studio. I'm happy to take any questions. There's one over there. Do you want to come up here, maybe?
Thank you very much. I'm very obsessed with this topic, so thank you very much. I had a question if you had any thoughts on the infrastructure that really enables this kind of work. You know, like there's Sam Altman, I think he needed $1 trillion loan from the Saudis at some point to create his own microchip to be able to kind of grow OpenAI.
Actually, the Chinese have just worked out, they've hacked into the chat GPT system, and they've discovered you can do it on the cheap. It is expensive to do all this at the moment, but who knows what exactly. What I would say is that in terms of expense, these things are actually pretty cheap. Robots are expensive. I go around the world in places like Egypt and things, and you can afford it. They're using it. These things, this is going to be like electricity. It's going to be absolutely everywhere. So I think the price is going to come down. That's what they're working on right now.
Hello. So you mentioned basically that humans using AI are going to essentially be worth, you know, a human and a half. So what would you do to ensure that you are ahead of that curve, that you're not going to be one of the so-called replaced humans without AI, especially, you know, when it is so accessible and anybody can create like these kinds of generative videos and the LLM usage, all of that. So how do you basically make sure that you are not obsolete?
I just want to put a little bit of context. We're actually from the art department and we're from the animation department. So this is a big concern for the students.
Love to be able to ease their minds on that.
Some people are doing very well out of this right now. I've got a friend in LA, Guven Chazal, teaches at UCLA. He's got a 4-person practice. He's teaching AI, using AI in the office. He's beating Gensler and all these big practices. You don't know Gensler, but this is a big architectural practice. And 3 or 4 people can do that. So there are lots of potential advantages here, but at the same time, there are challenges. I mean, to my mind, the real danger is that, you know, people could start competing for fees. And 4 people working on a project, they could drop their fees to 2%. That's a problem, right? Because the money coming into architecture is based on a percentage of the building costs. If you drop the fees from 5% to 2%, you've got 40% of the money coming in to architecture. And the danger of that is not going to affect, is that the profession becomes so badly paid that we might go the way of China. I mean, in China, nobody wants to do architecture because for different reasons, fees are already low there. So people don't want to do architecture. But if you get on board with this, now, there is a real danger, especially in schools of architecture and maybe art, I don't know, that with some of the professors, I'm sure not at FIU, who say, don't use AI, right? Now, I studied at Cambridge, right? I had a professor who told us, don't use computers in the studio. Now, what happened is the smart students were using computers and then doing a kind of like an overlay, sort of fuzzy hand drawing thing, just to pretend they haven't, right? The not so smart students were not using computers and they graduated and they were unemployable. So if any of your tutors here says, don't use AI, just do a fuzzy overlay on the top of it because you'll need this to become employable. And it's, yeah, you've got to come on board with this thing because and my worry, frankly, is education. I've been talking to practices, Foster and Partners, for example, as a firm in London. They are absolutely obsessed with getting on board with all these things, not to generate designs. They can do the designs, but to speed up the process to make things more efficient. They realize that. Practices realize that. Even some of these slightly stuffy organizations like the RIBA and the AIA, they're on board with that. But the real problem I've seen is educational institutions. I mean, the real danger, and this is a story that my supervisor told me at Cambridge years ago. There was a professor. Well, when he was young, was packing out the auditorium with his lectures. Towards the end, when he was about to retire, he had like 6 people in the front row, and he made this comment: "I don't understand what's going on. I'm teaching exactly the same material that I used to." That is the problem. We've got to mutate and change and be adaptive for a world that is getting changing faster and faster than we are. We need to get on board with these things. And education, we are sending you guys out into a world when the singularity is about to happen. You've got to be aware of these things. And I don't think it's going to diminish creativity. I think the really creative people will be thinking about how to use these tools in pushing the boundaries in imaginative ways. So all I would say is there are opportunities there for those who are smart enough to do this. I'd also say it's for architects is that actually one of the big challenges that we have as architects is that if you look at the pay scale of what happens in a building, the architects at the bottom, right? The developers at the top, then you've got the kind of quantity surveyor and the engineer and the architects way down there. But using these tools, we could reinvent ourselves and become developers because they're there to help you do that. There's a Mexican architect called Luis Barragan, beautiful architect. He was a developer. So we could reinvent ourselves. The other thing I'd say about architecture I find very interesting is that we visualize things. You know, you see an architect making a diagram of things, and the same I'm sure in the world of art, right? Other disciplines don't do that. And that, I think, allows us to visualize not just necessarily forms, but systems, how systems operate. It's interesting that Pinterest was invented by an architect, and that TED Talks were invented by an architect. Digital Futures was invented by an architect. If we use our imagination to rethink systems, not just making sexy forms, then we can go a long way. But I think above all, what any profession needs to do, I mean, certainly what I say about architects, what we need to do is not to design another building. We need to design the very future of our profession, and a future that is constantly mutating and changing. It's not just adapting now, we're going to have to continually adapt. The world is changing and we've got to go with it. But I see that as an opportunity. You want to come down and? Well, no, but on Zoom, they need to.
Hello, home audience. So Elizabeth Marsh, professor in advertising and public relations. I have 100 questions, no, maybe 300 questions that I want to ask you. But what I mostly want to say is, will you please come and talk to our students, maybe even exactly the same lecture, because our students need to use AI. If they don't use AI, they're not going to have jobs. And I can say that as much as I want, but I think you have a little bit more weight.
No, and what I would say is I'd be happy to, but also bring them here because, I mean, we've got a lineup of some astonishing people. So no, but you have to do this. And, you know, and what I'm always astonished by is it seems to be very obvious what I'm talking about, but every time I talk, people like say, "Oh, really?" So yes, we've got to get on board with that. Any final questions?
Thanks, Neil. That was amazing, and so much to think about. My question has to do with actually education, in fact. It wasn't that long ago, probably the 70s, when computer science in California was growing in leaps and bounds. Students were part of the general body, and when the industry started to really grow and develop, they became almost like just treated very differently and were somehow separated from this larger body of students. So it became a more curated conversations that happened within computer science. And I mean, amazing things have happened. The question about education has to do with, at what point do we turn this into a conversation that isn't about technical prowess, that isn't about these amazing things that blow us away, and more about the philosophical underpinnings, more about the knowledge itself, more about these imperfect things that define us as human beings. How, at what point, I mean, I think we should be having those conversations, but my question is, do you think that it's happening deeply enough? Is it, you know, where are those conversations happening? It seems like that is like very separate from the folks actually doing the mechanics and the sort of on the cutting edge of the technology.
Thanks. Good question. Actually, it's not. I didn't really talk about this, but Blaise, for example, his his wife, his partner, is a professor of neuroscience in the University of Washington. And the interface between neuroscience and AI is absolutely fascinating. That is the new debate, in terms of theoretical debates. I was teaching French philosophy, basically, Deleuze, Derrida, Barthes, Foucault, Cixous, whatever, back in the 90s. This stuff is fascinating. I didn't get a chance to go into it, but what is really most amazing is that this world is becoming a mirror to our own world. We are beginning to recognize ourselves in the mirror of AI. And that I think is fascinating. So, I also personally think that in terms of each individual discipline within architecture and landscape architecture, theory, history, and so on, these are all going to be absolutely, totally impacted by these technologies. It won't just be the design side. I gave a lecture in Melbourne. One of my former students was there with an app open, an AI app, and it was listening to my lecture. And then the instruction was to ask a question at the end. I was totally blown away by that question. It is going to really invigorate all the aspects of landscape architecture, art, and so on, especially, I think, the philosophical side of things. I think the real problem about philosophy right now is that it's failed to keep pace with science. And when Blaise was talking last, he was talking like a philosopher. I mean, he is absolutely astonishing, and not just him, but people like Anil Seth, who's a neuroscientist who did a PhD in AI. Anil Seth has got this idea that our understanding of the world is a form of controlled hallucination. And he's a rigorous scientist. He's arguing this through experimentation. Or Yosha Bach, who was also on Digital Futures, who says we're living in a kind of simulation. And he's arguing it very, very persuasively. There's actually a field of theoretical and philosophical debate behind all this that is mind-blowing, totally mind-blowing. But I just want to say something else about education, is I think I'm doing a book, hopefully with Joseph Choma of FAU and Aditi Makopoulou of IAC on education, because education is really a problem. And it has been a problem before even AI. We've gone from blackboards to whiteboards to PowerPoints. Nothing much has changed. But when we've had several discussions on Digital Futures about this, we had a particular guy called Sanjay Sama from MIT. He's the head of open learning at MIT. And he was saying, hold on a second, there is more information on YouTube than any professor knows. So it's pointless, the old-fashioned model of a kind of professor coming along and just dumping this information on the table, as it were. And we've got to shift and change. And the notion Reti talks about is we have to be a kind of curiosity stimulator by pointing people in the right direction. I think education is the biggest crisis right now because it really has been forced to change. And one of the things we did on Digital Futures, I don't know if you know the story of Digital Futures, we met in person. And in 2011, we had conferences and workshops and things. And then with COVID, we had to go online. And we went from 700 people to 20,000 people in 1 year. And now we're all operating online. And what is nice about that is that you're putting stuff online and there are people here listening. I know in Iran, in Bangladesh, they're listening to this particular lecture. And you're not just breaking down the physical wall of the classroom, you're also breaking down the social economic barriers that are preventing people from having access to things. And we believe that education should be a human right, not a privilege of the wealthy. So we can use these tools and these platforms that are not to do with AI to really change the way that we teach. And I think we've got to radically change the way that we teach. But personally, and this is a longer conversation, neuroscience is mind-blowing. When I look back, when I first started teaching in the mid-90s, that's when Zaha came onto the scene. We had Greg Lynn doing his computational stuff. We had Derrida and Deleuze. It was a very heady debate. But what's happening now is even more fascinating and exciting and terrifying and everything else. And we're just opening up to these things. But I think what's great about FIU, we've had some of the best people in the world passing through the Doctor of Design program, not just Guan Yu He, but also Philippe Morel, who runs the Masters in Computation and Architecture at the Bartlett, the top school in the world. And we're gradually building upon that. We've got several of the DJ students working on that now. So if we can consolidate that, we can really make this place somewhere special. So I just want to finish off by thanking Reekolect for investing in us. And let's hope we can build upon this because, I think we've got the real potential to make this place something special. So Thank you so much for contributing. And next week, we have Manuel Jimenez Garcia. His stuff is astonishing. Look up it, Nagami, Nagami, and you'll see he is one of the most extraordinary 3D printing designers in the world today. So thank you. Thank you.